So to start off, Dijkstra's algorithm we've learned in the last class that it's also called as single source shortest path. So basically, this particular Dijkstra's algorithm we know is used to find the shortest path from one source node to all the other nodes. So if you consider the program, the first step will be to get the graph. Only if you have the graph can you start finding the shortest path. Yes. So to get the graph, first thing we need to know the number of vertices. So the number of vertices present in the graph. Okay. So total number of nodes that are present in the graph. This is the number that will be useful for us to tell how many times or how many iterations our entire algorithm has to run. So it's the number of vertices in the graph. Then the next thing you need is the cost adjacency matrix, or in other words, all the edges that are present in the graph. What exactly is the weight value? So how do we accept the adjacency matrix? We create a two-dimensional array. Then cost adjacency matrix, you have two loops, one for number of rows and one for number of columns. And then we are accepting the cost values. Now in this, we are not going to make the diagonal elements as infinity. Main reason being, we are finding the shortest path, shortest distance from the source node to all the other nodes. So shortest distance from the source node to itself will be 0. So since the shortest path will be 0, we want to display that shortest path from the source node to itself as 0 itself. So there is no way we are going to make that the diagonal elements as infinity. So we're keeping them as it is, as in how we are accepting the input from the user. So this is used for accepting the cost adjacency matrix from the user. Now, after you accept the cost adjacency matrix, the next thing we need is from which source are we starting. Okay, so how do we accept the source node? Again, we'll have one source node and we'll accept the input of that particular source node. So this source node can be the first node, second node, third node, whichever node you want to start from. But from one source, we are starting and finding the shortest path to all the other nodes. So in order to find the shortest path, the algorithm we are going to use is Dijkstra's algorithm. So basically, we are calling the Dijkstra's function, and we are passing the total number of nodes. We are passing the cost adjacency matrix and the source node, because all three are required for finding out the shortest path. So that being said, the next thing that we need to know is how exactly does our Dijkstra's algorithm work. So I said Dijkstra's algorithm basically follows three steps. First step is initializing the shortest path from one node to all the other nodes. If there's a direct edge, you will initialize it to that particular value. If there is no direct edge, you'll initialize it to infinity. The second step that is followed is you will try to find the short distance of the node that has not been visited. Once the smallest distance is found, we will take that and we will add that vertex into the tree. Once we add that vertex into the tree of vertices, then through that particular node, we are going to find out if there is any update to the shortest distance from the source node. So these are the three different steps we are going to follow. And these three different steps, we are going to see how to write it into a program. So the first step was initialization. Yes. So I'm going to need one way of identifying if I'm visiting a specific node or not. So that is why I'll have something called as visited as well. Okay, just to see if I have visited each and every node. Now I need one to capture all the distance for each node from the source node. I'll have the initialization part. Now in this initialization part, if it is the cost adjacency matrix, you would have entered, if there is an edge, the cost value, and if there is no edge, you would have entered infinity. So the same values for all the nodes from the source node, we are taking from the cost adjacency matrix and we are putting it into a new array called as distance. Now after we do this, this is basically for initializing the edge weights. After the initialization step, the next step is finding the minimum value. Okay, so before that we'll have to visit. Okay, so we'll have this visited array. Source will become 1 because we are starting from the source, meaning we've already visited the source node. So all the other nodes, if it is not a source, not equal to source, then we will make it as 0. The reason why I'm checking like this is because your source need not always start from the first node. It can be any node. Now once this is done, so you're initializing the visited of all the other nodes except source to 0. Next, we are making count as 1. Why are we making count as 1? Because we've already visited one node. And when the number of nodes that you visited is equal to the total number of nodes in the graph, we are stopping. That is the ending criteria. And we are using this minimum to find out the smallest value in the graph. Okay, smallest distance. And we need to identify which node gives me that smallest distance. So ending criteria is count not equal to n, because count is the count of how many nodes we are visiting, how many nodes we are putting it into the tree. I'm making minimum as initializing minimum to 99. Why am I initializing it to 99 inside the loop and not outside? The main reason why I'm doing it is because every time I want to find the smallest distance. So that means every time I need to have my minimum as the highest value for each and every iteration of the count. How do I find the smallest distance? I'll check if the distance is less than minimum and that particular node is not visited. Only then I'm going to consider. Otherwise, the first time you are considering A to A as 0. The next time also it should not consider A to A as 0. So A I would have made visited. Now next A to B. So if I want to take A to B as the minimum value in this iteration, B should not be visited. So if this condition is false, this condition also becomes true if B is not visited, and this condition becomes true if A to B is the least value. So I would have selected A to B. But then in the next iteration, again it should not select A to B. So that is why we are checking for this condition. So in other words, once this condition is true, I need to make visited of that particular node also as true. Okay, so I'll make minimum equals distance of j, because initially let's say the distance from A to B is 8, distance from A to C is 3. Then initially I would have checked 8 less than minimum is true. So I'm making minimum equal to 8 and I'm taking U as the node B. So that being said, so this one is used for finding the shortest distance. Among all the distances that are there in this particular array, we're finding the smallest value and we are considering that based on the visited node. Okay. So once we find this, the next step is updating and making the visited of that particular node as 1 and then incrementing the count because now we've selected the next node as well. And after that, we need to update all the other remaining vertices. So for the updation part, we are using this particular j. So if minimum plus, minimum is the shortest distance that we've taken, plus from that particular node to the other nodes. If the value is less than whatever is already in the distance, like you saw for D, when we had to find from A to D. Through C, we were able to find a shorter value for D as 10 when C was considered. So minimum would become 6 over there. C of U to J will become the 4 value. So 6 plus 4 basically becomes 10. And we'll find that 10 is less than 99. And also D wouldn't have been visited. And that is why we will basically update that particular distance value. So this is how we are going on doing. So every time you are trying to find the minimum value and you're trying to update. So these two steps have to be put into a loop and they should be iterated till you find each and every node that can reach the destination. I'm sorry, till you found the shortest path to each and every node. And you've taken each and every node and you've put it into the tree vertices. So if you're doing that, then your count basically becomes equal to n, and we will stop the loop. Otherwise, basically, you will have to continue doing this. And your update initialization will happen only once at the beginning of your Dijkstra's algorithm. Okay, so you need to remember there are 3 steps which you do. First initialization step happens only once. The finding of the minimum distance and updating keeps repeating in the loop. Finally, what we are going to do is we have to display the shortest path from the source node to all the other nodes. And this basically is done, using the for loop. So from the source node to each and every node, what exactly is the distance that we've saved. So this we will display, and that ends your Dijkstra's algorithm. Now, how many loops did we see? We had, okay, if you take the main part of your Dijkstra's algorithm, you have one while loop here, which goes from count equal to 1 till n. Okay. Then you have your j loop, which starts from 1 to n again. And inside this, you have one more loop again, which is used for updating. So you have one loop for finding the smallest value, one loop for updating, and both of these loops is present inside your while loop. So if you want to compute the time complexity, this is not a recursive algorithm, so there is no recurrence relation. Instead, it's a non-recursive algorithm, so we need to go for summation procedure. Okay, so if you take summation procedure for time complexity computation, this will be the summation formula that you are getting. So you have I equals 1 to n minus 1, j equals 0 to n minus 1, k equals 0 to n minus 1. So if you take this into picture, how exactly do we solve this? We are telling we have one step here, which has to keep computing. So what's the formula used over here? Can you give me the summation formula for this? Anybody?
Upper case minus lower case plus 1.
Yeah, upper limit minus lower limit plus 1. So for both of these, it will be n minus 1 minus 0 plus 1. Okay. So same way, the next step is I am basically solving both these values. So once I solve both these values, you can see minus 1 and plus 1 gets cancelled in both the things. So you get n plus n. So I get sigma of I equals 1 to n minus 1, n plus n, which is 2n. Now 2n is not a value which is dependent on I. So it is a constant value, meaning I can take it out of this summation formula and I will be left with only 1 again. So this changes to 2n sigma I equals 1 to n minus 1 of 1. Again, the same formula we will be using like how we used here, correct? So this time it will be n minus 1 minus 1 plus 1. This one, because your count is already initialized to 1, whereas all the other for loops are initialized to 0. So you get n minus 1 plus 1. So this becomes minus 2 plus 1 minus 2 plus 1 is minus 1. So 2n of n minus 1 is the value. And if I multiply this, I get 2n square minus 2n. So 2n square minus 2n is the final value which we are getting. But if you see, the higher order power is n square. So finally we can tell the time complexity will be theta of n square. So if you are telling that time complexity is theta of n square, if you tell n as the number of nodes, which is also the vertices, then we can tell time complexity as theta of v square. So you understood how to compute time complexity, right? So like this, you have to compute the time complexity for each and every algorithm which we have learnt.
Uh, Coming to the execution part of your Dijkstra's algorithm, first thing what you have to do is you need to open the terminal. Okay, before you open the terminal, you need to basically open an editor. So you can give gedit, or even if you type ge, you may get a text editor option. You click and you open the file. After you open the file, you'll have to type the program. So when you have to type the program, let's type the entire program that we've learned till now. Okay. Uh, I shall copy paste. Yeah. Now once I finish typing the program, I need to click on save. When I click on save, I need to go into you can go into your folder and save, or I'll just save it on the desktop right now. So I need to give the file name. So let me make the file name as digi. Now, if I just press save right now, it is going to be a problem because it's a Java program. I need to save it with .java extension. So make sure you don't do this mistake. Once I save, you can see all the coloring comes properly. Otherwise, this coloring would not be there in the beginning. So after I finish saving, now next step is open a terminal. Now in this terminal, I will be in a default folder. So now I need to know where exactly I am. So let me just give ls. I can find that I am in the home folder. Okay. So now I need to go to the place where my file is. If you remember, I saved my file under desktop. So I need to check out where is desktop. So I can find desktop over here. So I will give cd space. Since desktop starts with capital D, I can press D and then E and the tab. Automatically it will take a give. Now that I am in desktop, let me see if my file is present. So each time make sure you have to see if your file is present in the folder under which you are there. If you don't check if your file is present in this particular folder and you try execute just giving a compilation command, you may get errors telling file not found. So always check if your file is there. Now I can find my file over here. So in order to compile the file, the command that is used for compiling the file is Java C. Okay, Java C stands for Java compiler. Now this should be followed by the file name that we've given, that is digi.java. If there are any errors, now it will show before the uh, terminal command prompt comes back. Okay, if there are errors, you can always go back here, make the corrections, save it, again come here and recompile. Now since there are no errors in this particular program, we need to run the program. So before we run, let's see what all files got created. You can see that there is a class file called as shortest which is created. Here if you see, it is not there. Here newly a shortest.class file has been created. So what we need to do, we need to run the program. So to run the program, you need to basically have the name of the class under which your main function is present. If you see, the main function is present under the class called as shortest. So I need to basically give Java. Java is the virtual machine which we are using for executing the program. So Java followed by the class name. Now remember, you should not give the file name here, but you have to give the class name for which the class was created. Okay, so this class should be the class under which you can see the main function. Okay, once you click and enter, it asks for the number of vertices. Now we'll take a simple graph with four vertices. So if you take this, now the adjacency matrix we need to give, or remember it's the cost adjacency matrix. So A to A is 0, A to B is 2, A to C is 6, A to D is infinity. Okay. Then B to A is 2, B to B is 0, B to C is 1, and B to C is infinity, and B to D is 1. Then C to A is 6, C to B is infinity, C to C is 0, and C to D is 2. And then D to A is 1, infinity, D to B is 1, D to C is 2, and D to D is 0. Now this is the cost adjacency matrix for the graph that we have chosen. Now I need to give source node. I can give any one of the source node. Accordingly, from that particular source node, I'll find the shortest path to all the other nodes. So let me give the source node as 1. If you see 1 to 1 is 0, 1 to 2 is 2, 1 to 3 is 6, 1 to 4 is 99, infinity. So now the shortest path that I should be able to find is 1 to 1 is 0, 1 to 2 is 2, 1 to 3 I'll find a smaller value as 5, and 1 to d will be 3. So let's see if we can get the same values over here. I've got the same values. So this is how you execute, but then make sure you are giving two other source nodes as well, and you are executing and seeing that if you are getting the answer correctly for all the other source nodes as well. This is how you execute your Digextra program. Thank you.
Okay, so this ends today's session. I hope you understood. Any doubts? You can ask me now.